In this video, we want to find the area of the region shaded. So there's two regions shaded here in pink, I guess it is. And it's a symmetrical curve. If you place the x by minus x and the y by minus y, it gives you the same equation. So we have a symmetry here. So we can find the area of one of the regions and just double it, and we get the region of both. So let's do this. I want to find these points here. So we place the y by 0. So I'm going to get the intercepts, the x-intercepts here. So replacing the y by 0, I get this minus x, the square root of 9 minus x squared. So you want to solve this equation for x. Well, the left side is 0. So let's check the right side. What values of x generate a 0? Well, you can see there when x is 0, the right side will be 0. So one solution is x equals 0. And then in here in the radicand, what is that 0? X is 3. 3 squared is 9. 9 minus 9 is 0, or negative 3. So the other intercepts in would be at negative 3 and 3. So this point over here would be negative 3, 0. This would be at 0 here, or the origin would be 0, 0. And this point over here would be 3, 0. So the area can be computed by finding the area of one of these regions. I'll take the first one here, negative 3 to 0. Negative 3 to 0. So it's the distance here, of course it's the y. So I draw a little strip here. The width would be dx, so this is integration with respect to x. This would be minus x then, square root of 9 minus x squared. Represent the rectangle here of length from the x-axis to the graph there, which of course is this, the function itself, this dx. That'll give me the area of one of these, and then we double it. Because of the symmetry, we can just double it here, and we get the whole thing. So first I want to integrate there. I'm going to use a substitution here. I'm going to u equal to 9 minus x squared. Then du would be the derivative of this, would be a minus 2x dx. So dividing by 2, I get du over 2 would equal 2 minus x dx. And then I'm going to change the limits of integration here using this substitution. So you can see when x, looking at the lower bound here, when x is negative 3, we get negative 3 squared, and then 9 minus negative 3 squared is 9, so 9 minus 9 is 0. So when x is equal to negative 3, the lower bound with respect to the u will be 0. And let's look at the upper bound, or the upper limit. At 0, we get 9 minus 0 squared is 0, so x will be 9. So when x is equal to 0, u will be 9. So now using the variable u, the limits of integration would be 0 to 9. So let's go back up here then. And now this is going to be multiplied by 2. And then of course I got the 1/2 here. So that's just this. I'm going to put the 1/2 here. That's this for the d over 2. So that's going to be 1/2. Cancel out. And then I write out the new integral here from 0 to 9. And the minus x dx over here. I already used up the 2 here. And multiplied the 2 in front. Is du. For the minus x dx, that's your du. And then 9 minus x squared, that's your u. So it's going to be u to the 1/2. I got that? And then we integrate with respect to u. So add 1 to the 1/2, that gives me u to the 3/2. And then divide the coefficient 1 by that, gives me 2/3. And then limits of integration again are from 0 to 9. So this is equal to, now we just substitute here. So it would be 2/3, replace the u by 9. This becomes 9 to the 3/2. minus 2/3, replace the u by 0. Just the 3/2, but that's not going to matter because that goes to 0. 2/3 and then 0 to the 2/3. 3/2 rather, is 0. So we're left with computing this out. So 9 to the 3/2 at the same thing as the square root of 9 is 3, and then you cube that, that's 27. So you got 2/3 times 27. So 3 goes into 27, 9 times 2 is 18. So the area of the two shaded regions in total is 18. Because we're dealing with area and we're not given the units, we simply say 18 square units. That's your solution. Thanks for watching. We'll see you next time.